In this video I'm going to be talking about another form of implicit wrong cutter methods called SDIRK methods. Now what I would advise is before watching this video that you have a look at the video on deriving DIRK methods, because SDIRK methods are an extension. So in the video on DIRK methods we saw that we had a method, if we had an S-stage method, okay, so we're just going to draw the butcher tableau for this. So we had some A11, A21, A22, and we had AS1, AS2, all the way up to AS. Okay. So we had this sort of arrangement for our butcher tableau. So this was a DIRK method. Okay, no, DIRK stands for diagonally implicit wrong cutter method. So that's a DIRK method. Now an SDIRK method is similar. Okay, we still have that sort of lower triangular sort of arrangement for A, but if I just write out this, okay, so instead of having we still have this lower triangular arrangement for A, but on this butcher tableau, A11, A22, etc. can be different. Now for SDIRK methods, what we say is we introduce an additional constraint that say all the numbers on the main diagonal will be the same. And of course, by the first row sum condition, we know that A11 has to be equal to C1. So what we're saying is that all the values on the main diagonal of A are all C1. Okay, and in doing this, it actually cuts down on the number of order conditions we have to solve for. Okay, so this is an SDIRK method. It's a form of a DIRK method, but all the values on the main diagonal are equal to C1. Now the derivation is very similar to the DIRK method. Okay, so what we use is coefficients. So what I mean by coefficients are A, B and C have to satisfy your BK condition, CK over 2 rounded down condition, and also they have to satisfy the B transpose times A times C is 1 over K factorial condition. Okay, so I'm going to talk through the example in the notes. Example is 3.5, and this is derive a two-stage SDIRK method. Okay, so our butcher tableau, if we just draw out the butcher tableau, so the unknowns, we don't know what B1 and B2 is. We'll have C1 on the main diagonals, so we've got another unknown, which is A21, and we need to know what C1 and C2 are. So if we count the number of unknowns, we've got C1, C2, A21, B1 and B2. So we only have 5 unknowns. So the B condition, and so the BK condition, this will give us B1 plus B2 is equal to 1. Will give us B1 C1 plus B2 C2 is equal to 1/2, and B1 C1 squared, because I don't know what. When we looked at the Radau and the Gauss-Legendre methods, we had a way of determining what C1 and C2 are, but we don't in this case, so we have to go a bit further in our order condition. Okay, we also need the row sum condition. Well, that first one's fairly trivial. So the other row sum condition is A21 plus C1 equals C2. So that's a row sum. And we've also got the B transpose times A times C equals 1 over K factorial. Okay, and that was B1 C1 squared plus B2 A21 C1 plus C1 times C2 equals 1 over 6. Just to sort of tell you where this comes from, so we have B transpose we always assume that the B vector is a column vector, so transpose it is a row vector. We have the A matrix, and this is from our butcher tableau, and we have our C values, and that's going to be equal to 1 over 3 factorial in this case, which is 1 over 6. Okay, so we have 1, 2, 3, 4, 5 equations. So we have 5 equations, and we have 5 unknowns. So with the SDIRK method, because we're actually saying we're given an additional constraint that the values on the main diagonal of A are equal to C1, it cuts down on the number of unknowns we have, and we can solve quite easily. So again, as I've been saying in previous videos, solving using software. So if we're to do that, and in this case we actually have a couple of different ways of doing it, well, a couple of different solutions. So we have C1 is plus or minus root 3 over 6, C2 gives us minus plus root 3 over 6. Don't have to solve for A11 because that's the same as C1 and A22. B1 is 1/2, as is B2, and the only other unknown is A21, which is root 3 over 2. So the solving this, there are a couple of different solutions depending upon these plus or minus values given here. Actually, I should have put a minus plus there. So we actually have two kind of different, I say different, they're the equivalent method. But so if we had let's say 1/2 minus root 3 over 6, we'll have 1/2 plus root 3 over 6. So that'll give us 1/2 minus root 3 over 6, so it has to be the same, so that's C1, and so that's that one, that's 0, and we all have plus root 3 over 6 here. We'd have the equivalent method if we just change all of these signs. Okay, so this is a two-stage, third order SDIRK method. Unlike the DIRK method, where there was lots of different ones which we just selected one of the unknowns and solved the others, in this case there's only 2 versions, which are found by alternating the plus or minus sign here.